For those of you who enjoy your seafood as much as I do, this thesis is for you, as the human health concerns of the levels of methyl mercury in our fish stocks are continuously increasing. Methyl mercury is a potent and dangerous human neurotoxin that's been linked to cardiovascular disease and also mental development problems in children. But how does mercury get from the ground, where it's usually found, into fish? Well, mercury is a unique metal that can actually exist as a gas in our atmosphere for weeks or even months. What this means is that emissions from industries such as coal-fired power or gold smelting can actually move beyond political borders and have real impacts on remote, otherwise pristine regions. In other words, mercury pollution is a global problem. But the journey from the smokestack to the fish stock is not a simple one. There's constant complex chemical reactions taking place, and there's also exchange of mercury from the air with soils and vegetation. Understanding these processes is key to developing efficient and effective methods of reducing mercury emissions. And herein lies our problem. To date, most mercury measurements have been taking place in temperate and polar regions of the Northern Hemisphere. This means that in the Australian continent, with our unique vegetation and our wide range of climates, modelling of the mercury cycle is largely untested. My thesis hopes to address this. We're using field-based measurements of mercury in the atmosphere to test and verify the models that we have in place. First of all, I'm assisting with the setup and the operation of Australia's first 2 long-term mercury monitoring sites. So far, the data have shown, or suggesting, that concentrations of atmospheric mercury in the Southern Hemisphere are around 30% lower than previously thought. In addition, I'm measuring directly the exchange of mercury between the atmosphere and Australian vegetation, as well as emissions from bushfires. We've been able to show that plants, vegetation, bring in mercury from the atmosphere and store it preferentially in their leaves and bark rather than the woody material. This means that in a bushfire, the type of fire and the intensity will have a large impact on the amount of mercury emitted. In the end, this effort will go towards furthering our understanding of the long-term and global impacts of anthropogenic mercury emissions to the atmosphere. From there, we can make informed decisions on how best to keep the mercury out of our air and off our dinner plates.